If you tear down a modern digital stylus, you will find a dense array of sensory technology. There are gyroscopes to detect barrel roll, haptic feedback engines, pressure sensitivity sensors, and magnetic wireless charging coils. At $129, consumers readily accept this density of features. It makes sense that a piece of plastic packed with microchips is considered a marvel of modern engineering. Then there is the traditional 10-cent wooden pencil. We treat it as a disposable, obsolete relic of the past, a primitive stick of carbon wrapped in wood. Producing this 10-cent object at scale requires an immense feat of industrial coordination, a process so precise we have become blind to its complexity. The mechanical problem begins with the raw materials. The pencil relies on encasing highly brittle, pulverized carbon dust inside a biological casing, cedar wood. By nature, wood wants to warp and expand with humidity. Without exact physical harmony between these opposing materials, internal tension causes the fragile inner core to snap the second you press it to paper. Mass-producing billions of these fragile composite objects demands microscopic, zero-tolerance precision. The solution exists far outside the digital realm. It requires stepping into the deafening, hyper-clean environment of automated modern manufacturing. The journey begins by completely destroying the raw materials. Silver graphite and kaolin clay are subjected to intense kinetic shock inside massive steel drums, pulverizing the minerals down to microscopic platelets. This diagram shows how the exact ratio of that mixture dictates the pencil's behavior. Blending in more clay yields a structurally harder, lighter line on the paper, the H grades. Adding more graphite creates a softer, darker mark, the B grades. Once the specific ratio is mixed with water into a thick, homogeneous sludge, it is extruded under massive pressure into thin strings and fired in kilns at white-hot temperatures. To prevent these hardened carbon strands from catching or dragging on paper, they undergo a final preparation step. They are soaked in a hot, pressurized bath of wax and oil until the pores of the material are completely saturated. The result is a highly calibrated, temperature-forged chemical compound designed for absolute control over friction. Meanwhile, the wooden casing is prepared. On the milling line, ultra-thin circular saws slice blocks of incense cedar into perfect, identical slots, specifically engineered to minimize any wasted sawdust. These slots pass through a groover machine. Spinning blades mill precise, semicircular channels into the wood, machined to a tolerance of mere fractions of a millimeter. Here is the highest stakes phase on the factory floor, the lead layer. The fragile carbon core drops into the milled groove, resting alongside a micro bead of flexible adhesive. Instantly, a second grooved slat slams down on top. Massive mechanical clamping pressure is applied to this wooden sandwich while the adhesive cures. This hyper-fast choreography resolves the structural tension. The flexible adhesive ensures that the brittle graphite and the shifting cedar wood will now permanently bend and flex together as one unified body. The assembled shafts are fed into a robotic inspection line. Lasers scan every single pencil moving across the belt, evaluating them for geometric symmetry and absolute concentricity. At the same time, acoustic sensors listen to the microscopic resonance of the wood as it rolls. If a microphone detects a hidden internal fracture or warped core, a pneumatic piston instantly fires, ejecting the defective unit from the line. The surviving pencils enter the finishing phase. Mechanical arms moving faster than the human eye plunge the shafts through up to 10 microlayers of lacquer, building a flawless, mirror-like gloss. The manufacturing process concludes with a violent mechanical action. A razor-sharp press crimps a precision-stamped metal ferrule onto the end of the shaft, permanently locking the eraser to the wood in an unbreakable grip. Through a gauntlet of robotics, chemistry, and fluid dynamics, raw earth materials are tamed into a state of perfectly smooth geometric utility. Pulling back reveals the immense scale of the operation. A single optimized production line can mill, glue, and shape 3,000 pencils every minute. Globally, over 14 billion pencils are manufactured every year. If you connected them tip to eraser, that continuous golden ribbon of perfectly centered graphite would stretch across entire continents. Yet despite towering walls of automation and laser arrays, the final judge on the factory floor is distinctly human. Master lead graders walk the lines, manually sharpening and testing the product by hand. They are looking for specific tactile proof. An unbroken, continuous curl of shaved cedar and a deep scratch-free carbon transfer on the page confirm that the kiln temperatures and extrusion algorithms were perfectly calibrated. Advanced engineering exists far beyond microchips and touchscreens. To drag a simple wooden pencil across paper is to experience the culmination of industrial perfection.